All right, radicals day 3, multiplying and dividing. So we've talked a little bit about this before. When you are multiplying two different radicals, a square root of 9 times the square root of 4, you could simplify that and have it be the square be 3 times 2, which of course is 6. Or square root of 9 times the square root of 4 can be written as the square root of 36, which is also 6. So in this case, either of these works just fine. However, if these were not perfect squares, then multiplying them together and putting them, then factoring them in a different way may help you more. So this one, square root of 144 is 12, and this is 3 times 7, and then you would just multiply all of those together. All right, which is 252. Okay, on ones like this, you will notice that the square root of 2 is not a perfect square, nor is the square root of 10. So sometimes when this happens, you will want to multiply these together. That's what's indicated here anyway. This would be similar to a 4x times a 3x, where you would do 4 times 3, which is 12, and then x times x is x squared. So same type of process here. We're going to do 4 times 3 is 12. And then the square root of 2 times the square root of 10 is the square root of 20. And then that does have a perfect square factor. So we will factor that down into the square root of 4 times the square root of 5. Of course, the square root of 4 is 2. 2 times 12 is 24. So this one is 24 times the square root of 5. Okay, this one is distributing, works basically the same way. So square root of 2 times 4 is 4 times the square root of 2 plus this 2, okay, you can think of this as there being a 1 out in front of that. So 1 times 2 is 2. The square root of 2 times the square root of 3 is the square root of 6. These are not like square roots, so on this one we will just stop right there. Stop right there because neither one of these has a perfect square root factor. So this would be similar to 4x plus 2y. We're just finished. You cannot combine those. When we square, squaring on a parentheses is kind of like distributing, so you can think of this as 2 squared and then the square root of 7 squared. So 2 squared is 4. The square root and squared are opposites, so really they cancel each other out. So that is just going to be a 7. So if you square rooted 7 and then squared it, you would get 7. And 4 times 7 is... Okay, and then moving on down here, properties of radicals. We've talked about this before, how you can divide a square root of a fraction into the square root of the numerator over the square root of the denominator. So this one we could rewrite as the square root of 25 over the square root of 16, which is this just then 5 over 4. This one we're going to rewrite as the square root of 5 over the square root of 36. And square root of 5 does not have any perfect square factors, so we leave that. And we have 6 in the denominator. This next one, the square root of 63 is not perfect. The square root of 100 is. So our denominator is 10. Up here, we have to factor out any perfect square factors. So I'm going to change this one into the square root of 9 times the square root of 7. So the square root of 9 is 3. We leave the square root of 7, and 10 is our denominator. This next one, on the denominator, let's look at that one first. We have negative 3 times the square root of 100, which is 10. On the top, we do not have, the square root of 27 is not a perfect square, so we can again factor that into the square root of 9 times the square root of 3. So coming down here, square root of 9 is 3 times the square root of 3 is what we have on top now. On the bottom, we have negative 30. Now, what we could have done before we multiplied those together is we could have canceled this 3 down here with the 3 up top. We can do that now, though. We can divide both the top and the bottom by 3 or reduce them. And so 3 divided by 3 is 1. I don't have to write that. You can if you want to put that 1 out in front. And then dividing the bottom by 3 is going to be -10. And all of these are fine, all of these final answers, because we do not have a radical in the denominator. When you do, you have to do something called rationalizing the denominator. So in this one, 2 up top in the numerator, square root of 3 is in the denominator. This is not a perfect square, nor does it have any perfect square factors. So we are going to multiply this by 1. You can multiply anything by 1 without changing it. The form of 1 that we are going to choose is the square root of 3 over the square root of 3. So anything divided by itself is 1. So basically, I am just multiplying this fraction by 1. The reason I have chosen this, you'll see here in a second. 2 times the square root of 3 on top. On the bottom, the square root of 3 times the square root of 3 is the square root of 9. And then what is the square root of 9? 3. So now again, we have no perfect square factors underneath the radical, and we have no radicals in the denominator, so we are finished. Same thing on this next one. We have square root of 5 on the bottom. Nothing we can factor out, no perfect square. So we're going to multiply this. This is called rationalizing the denominator. We're making the denominator into a rational number. So when we do this, the square root of 3 times the square root of 5 in the numerator is the square root of 15. In the denominator, we have 2 times the square root of 5 times the square root of 5, which is the square root of 25. So numerator, square root of 15. Denominator, we have 2 times 5, which is 10. Okay, one more time with this one. 10 on top, square root of 8 on bottom. We're going to rationalize the denominator. So we're going to multiply by the square root of 8 over the square root of 8. On top now we have 10 times the square root of 8. In the denominator, we now have the square root of 64. 8 times 8 is 64. Numerator, we have 10 times the square root of 8. Denominator, we have an 8. Now, kind of ignore this radical for a moment. If you just had 10 over 8, you can divide both of those by 2 and reduce that to 5/4. But we still have this square root of 8 up top. So now we're finished. Oh, wait, my bad. We are not. We do not have any radicals in the denominator, but 8 can be factored into the square root of 4 times the square root of 2. We cannot stop if anything under a radical has a perfect square factor. So, and I'm sorry, I'm running out of room here. I'm going to go down here. This square root of 4 is 2. 2 times 5 is 10 times the square root of 2. And in the denominator, we have 4. So we can, again, 10 over 4 can be reduced to 5/2, and this square root of 2 is still hanging out up top. So that one got a little lengthy, but I think you can follow that along. Again, you are finished when underneath the radical there are no perfect square factors, and in the denominator there are no radicals. If there are radicals in the denominator, we rationalize it. All right, this last one, we can factor this, or really rewrite this as the square root of 4 over the square root of 27. The square root of 4 is 2, and the square root of 27, let's go ahead and break that down first. We could multiply by the square root of 27 over itself, but let's break that down into the square root of 9 times the square root of 3. So now we have 2 over 3 times the square root of 3. Almost finished. What we have under the radical has no perfect square factors, but we cannot have a radical in the denominator. So we need to multiply, we need to rationalize the denominator. Multiply by the square root of 3 over the square root of 3, which is 1. So I'm going to move down here. So now on the top, we have 2 times the square root of 3. In the denominator, we have 3. That's from here. Square root of 3 times the square root of 3 is the square root of 9. So we now have 2 times the square root of 3 in the numerator. In the denominator, we have the square root of 9, which is 3. And 3 times 3 is 9. All right, the last couple here. On this one, You can always reduce a fraction. So we could rewrite this as the square root of 5 over the square root of 45 and then rationalize the denominator. However, let's make this easier on ourselves. Let's reduce this by dividing both the numerator and the denominator by 5. And so now we have 1/9. This is going to make this super easy. So this has the square root of 1 on the numerator, square root of 9 in the denominator. Square root of 1 stays there. Square root of 9 is 3. Boom, we are done with that one. So no radical in the denominator under here does not have any perfect square factors. All right, last one. So 32 over 75. This can divide by 16 and 2 and 4 and 8. 75 can divide by 5, 15, 25, 3. So they do not have any common factors. So it doesn't seem like we have any choice. I'm going to make myself some space here. But to do what we know how to do, square root of 32, let's try to break that down. So we have the 1/2 is going to stay out in front, okay, and 1/2 is a fraction. So I'm going to put the 1 in the numerator, then 2 in the denominator. And then I can rewrite this as the square root of 32 over the square root of 75. Okay, I'm going to put my 1 again, put my 2 again. Square root of 32, we can break that down or factor it into the square root of 16 times the square root of 2. In the denominator, the square root of 75, we're going to make that factors of 25 and 3. Let's keep going. I'm going to show all this. So this is 1 times the square root of 16 is 4, and then times the square root of 2. Denominator, we have 2 times square root of 25 is 5 times the square root of 3. So numerator, we have 4 times the square root of 2. Denominator, we have 10 times the square root of 3. So right now, underneath this radical, there are no perfect square factors. Same here. We're almost finished. We cannot stop when we have a radical in the denominator. So we need to rationalize, multiply by this square root over itself, which is a form of 1. And so then up top, we have 4 times the square root of 6. So we have this 4 times a 1 that's out front, and square root of 2 times the square root of 3. In the denominator, we have 10 times the square root of 9. So I'm going to move down here. Up top, 4 times the square root of 6. Down below, we have 10 times the square root of 9, which is 3. A couple more steps here, and I'm showing every little part. So 10 times 3 is 30. Now, 4 and 30 can be reduced. Anytime you can reduce your fractions, you do. We can divide both of those by 2. So 2 times the square root of 6 over 15, and that one is finally finished.